Continuing solving systems using elimination, remember what we're trying to do is eliminate one of the variables. So we have to pick either x or y. In letter D, what I'm going to do is I'm going to cancel the x's because I'm looking at 3 and 12, and I notice that those are a little bit smaller than 7 and 28. So I'm going to multiply this top equation by 4, and when I multiply it by 4, it becomes negative 12x plus 28y is equal to 20. This case is unique also because when we're looking at it, notice that both of them cancel. So we end up with a 0. 10 and 20 add up to 30. These two numbers are not the same. So we're not going to put infinite amount of solutions like what we did last time in A. What we're going to do is we're going to put no solution. The reason that we put no solution is because 0 never equals 30. Notice that there's no variable. So these are the only possibilities. So it's always never going to work. Now, looking at letter E, what we have to do is we have to decide which variables do we want to cancel. When I'm looking at this, what I want to do is I want to cancel the y's because 3 and 4 are smaller numbers than 9 and 5. Remember, I'm looking for the least common multiple. So what number does both 3 and 4 go into? And that number would be 12. So I'm going to multiply my top equation by 4. And when I multiply it by 4, I get 36x plus 12y equals 72. Now I'm going to multiply the bottom equation. Once again, what I want are opposites. This is a 12, so I want a negative 12. It's already a negative 4, so I'm going to multiply it by 3. When I multiply it by 3, I get 15x minus 12y equals 30. I'm going to combine the two equations. When I combine the two equations, these two right here add up to 51. The y's cancel, they become 0. 72 plus 30 is 102. I'm going to divide each side by 51. So x is equal to 2. Now what I need to do is plug it into one of the equations. I have to decide, do I want to pick the top equation or the bottom one? I'm going to pick the top. I think it looks easier, but it doesn't matter which one. I'm going to plug a 2 in for the x. 9 times 2 is 18, plus 3y equals 18. I'm going to subtract 18 on both sides. I get 3y equals 0. So when I divide it by 3, y is equal to 0. Remember, I'm going to write it as an ordered pair. X comes first, y comes second. My answer is 2, 0. That's my ordered pair. Looking at the last example, what I want to do is I want to create opposites. So I'm deciding x or y. My choices 2 and 3 or negative 7 and 6. I think 2 and 3 looks a little bit easier. The least common multiple for 2 and 3 would be 6. So I'm going to multiply the x by 3 on both sides for the top equation. And that gives me 6x minus 21y equals negative 24. For my second equation, I need opposites. If this is a 6, the opposite of a 6 is a negative 6. So I need to multiply this by negative 2. When I multiply by negative 2, I get negative 6x. Notice we have opposites. I get negative 12y, and I get negative 42. Opposites add up to 0. This gives me negative 33y equals negative 66. When I divide by negative 33, y is equal to 2. Now, I found y. What I need to do next is I need to find x. I need to pick one of the two equations. What I'm going to do is I'm going to pick the bottom equation this time. Once again, it doesn't matter. When I plug it into the bottom one, I have 3x plus 6 times 2 is 12 equals 21. I subtract the 12. 3x is equal to 9. So when I divide it by 3, I get x is equal to 3. Remember, my answer is an ordered pair. X comes first, y comes second. So my ordered pair is 3, 2.